and also something called a composite function or a composition of functions. And then tomorrow we're going to look at inverse functions. So what are we doing? Like, how can we work with functions, different things we can do with functions. Pretty much every day will be like a new piece to add, to build on to the material that we're talking about. One day just kind of builds on to the next day. So at the bottom, Friday, we were talking about 4 combinations, 4 ways we can combine functions. And these 2 functions are the exponential functions, or the power functions that we've been working with. So we have those fractional exponents. And it just says f plus g. So what does that mean if you're supposed to have f plus g? What are you supposed to do?
Above, it shows what f and g is, so you just add the 2 together.
Yeah, so you take the function that represents f, which is the 5x to the 2/3, or 3/2, not 2/3. You're adding that with the function that represents g, which is a negative 2x to the 3/2. And then, Julia, can you add these together?
Yes.
Because?
Exponents are the same.
Right, so the variable and the exponent is the same, so you just add the coefficients in front and you get 3x to the 3/2. So then underneath it, there are 4 different pieces dealing with domain. So it also wants us to find the domain of the problem. And to get the domain, you need to think of the domain of the original problem. So the original 2 equations that we're starting with, we need to think about those domains. If you rewrite this, you have a 5, and then 3/2 is really the square root of x cubed. So this is negative 2 square root of x cubed. That's how we would write it as a radical. So it's given to us as an exponent, but if we are writing it as a radical, the denominator is the square root, the numerator is the power. So when you're thinking about the domain and there's a square root in the problem, this guy right here, that's the important part. Because there is a restriction or a value that can't be included in the domain of a square root. Does anybody know what the domain of that would be? Or how you find the domain of the square root of x? What can't be underneath the square root? Jillian? Negative numbers. So that means whatever's underneath there has to be greater than or equal to 0, because you cannot have negative numbers. The cube part doesn't matter. It's the square root part that matters. So anytime there's a square root, doesn't matter what the power is, if it's a 4, a 5, a 6, an 8, a 15, a 21, a 101, it's the part that the square root is in the problem. So if it's greater than or equal to 0, that means our domain has to start at 0 and go to infinity. And because they're exactly the same radical, the domain for each of them is the same. So a square root can't be negative. The other exception or exclusion was when there's a fraction, you can't have a 0 in the denominator of the fraction. Those are the 2 restrictions we talked about last week with domain. So when you go to list this domain, because both of these have the same domain, this is also going to have the same domain. So it'll be from 0 to infinity. And you can see the power of it is exactly the same as well. So this second one wants us to take f of x and subtract g of x, which is pretty much exactly the same thing, except now we're subtracting the 2 functions. So f of x minus g of x. Odette gives you?
7x to the 3/2.
Does the domain change? No. It's still the same 2 original functions. The power or the exponent is still the same. So 0 to infinity. So the third one wants us to multiply. So we're taking f of x, and we're multiplying this with g of x. So we have 5x to the 3/2 times negative 2x to the 3/2. Mackenzie Myers, what are you doing when you're multiplying them together? Yeah, so you're multiplying those coefficients. So that's a negative 10. And then you're adding the exponents. When the base is the same and you're multiplying, you add the exponents together. So Mackenzie, if you have 3 halves plus 3 halves, what power does that make? Say it again. To the third, yeah. So you're taking 3 halves plus 3 halves, which you add the top together, bottom stays the same. That's 6 halves, or to the third. My daughter is just starting common denominators in 5th grade. So she was getting least common denominators for all of her fractions last night. They just started it. And they never go away. And she likes fractions right now. So this domain is the same as the initial 2. Even though this exponent changes, it still goes off of the initial 2 domains. So this domain would be from 0 to infinity. So it doesn't go off of the answer, it's from the initial 2 functions. The domain is always based off of the given information, not your result. And then the last one says take f of x and divide it by g of x. So f of x is 5x to the 3 halves, negative 2x to the 3 halves. Emma, what's that answer become?
10x, because you put negative 2x in the
Does the negative, is it as an exponent? No. So the only time we move it is when you have a negative exponent. Otherwise, it's just a negative number and it's going to stay where it is. So the 5 and the negative 2 aren't going to move at all. What did you say happened with the x's? You subtract them. So x to the 3 halves, x to the 3 halves would just be a 0. X to the 0 would go away. So this answer is actually just 5 over negative 2. Because these x's have the same power, they cancel. Or 3 halves minus 3 halves is 0. X to the 0 is 1. It's gone. This domain has one little difference than the other 3 domains. Does anybody know what the tiny little difference is? It's just a little difference. Because this one has a fraction, and the other 3 did not. Jeff, do you think you know what the difference is?
Is it that the denominator can't be equal to 0, so you'd have to have 2 parentheses?
Exactly. So the only difference from the 4 domains is when you have a fraction, your denominator cannot be 0. So that means you can't have a 0 in for x. It's allowed to be anything other than 0, and it has to be positive. So the only difference from the domain when you're doing a fraction should be the 0 gets a parenthesis, and all of the others have a bracket. So the same domains, except for the last one because it's in a fraction. All fractions have to exclude the 0 from the domain. Questions? So Julian is going to go over number 8 from your homework. I'm going to come around and grab those factoring worksheets from those of you that are sitting in the front. But this one cannot. I don't know if were these your original questions?
Yeah.
So the one can't. So it always goes with the one that can't overlap with them.
So the negative thing is here.
Well, can this be negative? So like think of each domain individually. Because that is a square root domain.
All right, so the problem asks you to do g minus f, which will give you f, 5 times x to the power of 1/3 plus 4 times x to the power of 1/2, minus negative 3x to the power of 1/3 plus 4x to the power of 1/2, which would give you 8x to the power of 1/3. So, because the top one, this one, the 5x to the power of 1/3, has the 1/2, which would be the square root of 4, well, of x times 4, then it would have to be from 0 to positive infinity.
And it would be a bracket with the 0, because his first function is 4 to the x to the 1/2, which is the square root of x, and a square root can have a 0.
Oh.
So it would be from 0 to infinity with a bracket around the 0.
Okay. Like that?
Anytime there's a square root, it's greater than or equal to 0.
I think I understand this better.
Questions? So Holly has number 27, which if you were able to figure out that last group of problems, awesome. If you kind of looked in the book to see what was going on or tried to use substitution. If not, we're going to talk about those today as well. These are kind of like substitution problems.
Okay, so for number 27, you had to substitute negative 5 into negative x squared and plug negative 5 into that equation. And you had to do negative 5 squared, and then you had to multiply negative 1 and 25 to get 625. And then you multiply negative 1 and 625, and then you get negative 625.
So Holly, if you don't mind just keeping yours up and sit down. Nice job. So just to kind of show you, this is what 27 looked like. This was the equation for g of x. And we're going to talk about a couple of these in a little bit. So inside here, negative 5, she says substitute it in for x. So wherever there's an x, you're plugging it in. It's substitution. And then she actually evaluated negative 5 squared. That's how she got the 25. But there were two g's. It was g and g, so you had to do that twice. That's why she has a square and another square. So then she squared that again and got 625. The negative in front of the x is the last thing that gets done, and that makes it a negative 625 because of that negative sitting in front of the x. Nice job. Nice job. So today we are going to work through some problems using these functions, continuing to talk about their domain and their range. And if you look at page 15 in your packet, we have a bunch of examples to work through. So lots of problems to kind of just go over, practice, look at. My notes disappeared. There we go. So combinations, adding, subtracting, multiplying, dividing. Those are your 4 combinations. When you find the domain of them, you're using the domain of the original problems. A composite function is another operation involving 2 functions. one is more using substitution. So a composite function has parentheses in it, but these parentheses don't mean multiplication like our typical parentheses do. So this means we're essentially taking one function and substituting it or replacing it in for another function. So we would read this as f of g of x. So the parentheses are actually like the word of. So it doesn't mean multiplication. I'm not taking f times g of x. We have a little times symbol there. So this notation represents a composition function. So we're trying to take these two functions and still combine them together, but we're combining them together using substitution. Whatever's on the inside is the part that's getting substituted to the outside equation. So the inside part is what we substitute to whatever's on the outside. So we have to kind of focus on the variable inside versus the variable outside, or the function inside versus the function outside. When we're talking about the domain, because we're going to work with the domain still, you have to find the domain of the inside function, which in this case is g of x, and the domain of the answer. We're going to see if we can try and start with it numerically and then look at it algebraically just with variables. The first one does not ask us to find the domain, but it does give us two functions, so you have to start with two functions. So we're now working with these two functions, trying to find different ways to combine them. For example 3, it wants us to have f of x being 2x minus 7 and g of x being x plus 4. X squared plus 4. It says what is the value, which means we're going to find a number, of g of f of 3. So g of f of 3. And we're going to start inside first. Because order of operations say that you're supposed to work in the parentheses, that's what P stands for from PEMDAS, and work your way outside of the parentheses. So we're going to start with this f of 3, and I'm just going to separate it. And look at it as its own separate piece. So I'm going to take out f of 3 and just rewrite it. What does it mean that you're supposed to do if a problem says find or evaluate? What's the value of f of 3? So what does that mean you're supposed to do to the equation? Connor?
You solve for 3.
And what does this 3 replace?
X.
X. So that 3 replaces x. So you go to the f equation and you replace x. And we did this last week on that domain and range worksheet that we were looking at, the small domain and range packet. So in the f function, instead of x, we're writing a 3. That's what that means. Whatever is in parentheses replaces x in the function that's outside the parentheses. So Connor, this gives us a -1. So f of 3 is equal to -1. Here's where the substitution part works. We're going to take this -1 and substitute it, because now I have an answer for f of 3. So I'm taking out f of 3 and replacing it with the number -1. So we found an answer for f of 3. We're going to go and replace that f of 3 with its answer. And now we're going to do the problem a second time, except this number goes in place of g. This still represents x, but now we're using the g function. So the g function says x squared plus 4. Well, x is -1, so we have -1 plus 4. So substitution kind of happening twice there. So you're replacing f, or x in the f function, you get an answer, and then you move to the g function. So Julia, -1 squared plus 4 is 5. So it said find the value of g of f of 3, and that value is 5. And we kind of broke it apart into two separate steps. So we did the middle part first, we got that answer, and then we looked at the outside letter. Questions? So the second group of problems here are taking us now into the variable form. So now we're going to keep the variables instead of plugging in a number for the letters. But we're going to see if we can try and apply it the same exact way. Before we go to answer any of the problems, I want us to think of the domain again. So if we can start with the domain, that helps us in the end when we try and answer the domain. So if you go and look at f of x says 4x to the negative 1. What is the other way that you can write that equation instead of having it as 4x to the negative 1? How else can that get written? Connor?
1/4x.
You're so close. What part has the negative exponent to it, Connor? The x. So the x is the part that's moving. The 4 isn't because they're not grouped together in parentheses, so they're actually not glued or attached together. So the 4 gets separated from the x, and this becomes 4. The x is the part that moves to the bottom because the x is the part that really gets the 1 over it. So it would be really 4 times 1 over x, but the 4 doesn't have a negative exponent. So if that's our equation, and x is in the denominator, we know that that cannot be 0. So when you have a fraction, whatever's in the denominator cannot be 0. So what would the domain of this function be? If we have 4 over x, what's its domain, Julia?
Parentheses 0, comma, infinity, parentheses,
That's half of it. What's the other half?
negative infinity, comma, 0, parentheses for both.
Yes. So it would be negative infinity to 0 and 0 to infinity. So it can't be 0, but it has to be every other number. So it goes from negative infinity to 0, not allowed to be 0, so it has to hop over it and go from 0 to infinity. Our g of x function is 5x minus 2. Will, what do you know about that equation? 5x minus 2, what's that graph look like?
It's linear.
It's linear. What's the domain of any linear function?
Negative infinity to positive infinity.
Good, negative infinity to positive infinity. All right, so let's now see if we can do the problem. We've got the domain. See if we can work on the problem. So this says f of g of x. It doesn't mean to multiply. A multiplication symbol would be there. It would look like multiplication. It would have a time symbol. So we're going to use substitution, and we're going to work on the inside because that's what PEMDAS tells us to do. So g of x is on the inside. We're going to take out g of x. And we're going to replace it with whatever equation it's equal to. So here's a little bit of substitution. The f stays on the outside because we're not working with that. We're working with the inside piece. The inside part is g, and its equation is 5x minus 2. So we're taking out the g and replacing it with 5x minus 2. So all I've done there was I've taken out a variable or a function and replaced it with its equation. So now what do you think you would do next? So we have f outside and 5x minus 2 inside. Julian, what do you think?
Plug in f 5x minus 2 for f.
Yeah. So now we're going to look at this inside part, and we're going to go to the other function, the f function. And it says 4x to the negative 1. Well, instead of me writing x, we're using substitution. So this goes back to chapter 3. When it's equal to something, you're allowed to take out a variable and replace it with whatever that happens to be equal to. So instead of having an x to the negative 1, we're going to have this 5x minus 2 to the negative 1. That's substitution. Take out a letter, replace it with whatever it's equal to. So all of this has a negative 1 exponent, which means all of that has to move to the bottom of the fraction. The 4 is separate. It stays on the top, this whole piece here moves to the bottom of the fraction. So now we have a 4, and then on the bottom is 5x minus 2. Because that was the g function. And we replace the g into the f, which is kind of weird. So now we need to do the domain. And to do the domain, we're going to really focus on that answer this time because there's a fraction in our answer. And when there's a fraction, the denominator cannot be 0. So if you solve that little equation where it says 5x minus 2 cannot be 0, Melanie, what does that mean that x cannot be? So get x by itself for the denominator. It cannot be 2 over 5. So taking the 2 to the other side, dividing by 5. That's how you're finding that number. You're solving for x. Melanie, do you know how you would write that then in interval notation showing it cannot be 2 over 5? Exactly. So anytime you say it can't be this number, that's when you write the 2 sets of parentheses. So negative infinity to 2 over 5, 2 over 5 to positive infinity. Questions? All right, let's see if we can try the next one. So we're using the same 2 functions, the same 2 equations, but they flip-flopped it. So now g is on the outside, f of x is on the inside. So we're going to see if we can work through it the same exact way. We're going to start here. We're taking out f of x and replacing it with the equation that represents f of x, which is 4x to the negative 1. So now this says that we're going to take whatever's in parentheses and go to the g function and use substitution. So in the g function we have a 5 and then there's an x and a minus 2. So that's what my skeleton should look like for the equation essentially. 5, I'm supposed to have an x minus 2. Whatever is going to go in for x is what's in the parentheses that I have written above. And that should be 4x negative 1. So we're going to try and simplify this as well. Inside here, we said 4x to the negative 1 can really be written as 4 over x. And then Julia, do you know what that becomes? It says 5 times 4 over x minus 2.
Would you like distribute the 5 to both parts of it?
If I made it 5 over 1.
It would be like 20 over x.
It would be 20 over x and then minus 2. So wherever the denominator is, right here, the 2 doesn't have a denominator, it's just a minus 2. That cannot be 0. So Emma, what does that mean the domain would be if x cannot be 0? So notice the domains are totally different because the bottom of the fraction is totally different. Okay, so have a third one here with these equations. Trying to do the same exact thought process. So we have f of x. We're taking out f of x, keeping the outside variable. And then we're taking whatever's inside here and replacing it for f. Well, f says 4x x, negative 1. So this is what my original equation is supposed to look like. Whatever's in parentheses is going to replace x. Because it says 4x, negative 1. So I have 4, something in here is x, and then the negative 1. And that something is 4x to the negative 1. So this is using composition of a function in the same function. Alright, this one's a little tricky. So what has to happen to simplify this? This looks like some of the problems we did at the very beginning of the chapter before Christmas. What gets done first to simplify? Comment? Yeah, so this middle part gets moved to the bottom. So the 4 stays outside, which is on the top. Everything that's in parentheses has a negative exponent, so it moves to the bottom. So whatever was in parentheses had a negative 1, all of that moves to the bottom. All right, now what do? Still have to simplify. Garrett, what else do you think we could do to simplify?
Both the fours can just turn into
Yeah, both those 4s just turn into a 1. And then there's one other thing, Garrett.
oh, we have to send that x negative first to the top.
Yeah, this x to the negative first goes back to the top because it has a negative exponent. So now my answer is just x. Questions? Emma, what's the domain of x? So that one was tricky with the simplifying. So whatever's in parentheses has a negative 1 on the outside, so that whole thing went to the denominator. Our 4s could cancel, so they're gone, leaving us with just a 1, but then that x to the negative 1 can get bumped back on the top. So I believe there's a couple examples underneath. Let's see if we can try to do one more example here. So why don't you see if you can try and start this, starting on the inside, using substitution. So now we're going back to the number. We're plugging a 5 in. We're using substitution. So always work on the inside. You're either replacing the entire inside with an equation, or you're using the inside and replacing a number. So in the F equation, we're replacing the x with a 5, which gives us 7. So then you're taking this 7 and taking out F of 5. So now it says G of 7. So try not to do too much in one step. Take it piece by piece. What's 2 times 49? Well, 98. So your homework. On the back are the solutions. Please do them on a separate piece of paper. And then anybody interested in trying 15, Julia, and 24. Brandon, 24. Have an awesome day.